Okay, we're going to be doing numbers 23 and number 24 in this video to help you out with the homework. So let's see. So in this example right here, what I'm going to do first is I'm going to pull out this 5 over 2. That's my first thing because that's going to make taking the integral easier. So I'm going to pull out the 5 over 2, rewrite my integral. And I have this. So at this point, once I pull this out, I'm basically, with these two right here, just have to use my power rule, x to the n plus 1 divided by n plus 1. So I'm going to go ahead and use the power rule right here. I want to make sure I do pay attention to bring that 5 halves down. 5 halves comes down. This is going to be negative 4, x to the, and the 4 plus 1 is 5, divided by 5, because 4 plus 1 gives me my 5, minus, and then 1/4 plus 1. If you do 1/4 plus the 1, that's 1/4 plus 4 over 4. That's going to give me 5 over 4. Divided by n plus 1, again, 5 over 4. At the end, we will add in this plus c. So that's what I have so far. As you can see, the 5 half, I have it written out in front. At the end, I'm going to put my parentheses here because at the end, the 5 half is going to go ahead and multiply into each and every single component. That is a little tricky. You want to make sure you do distribute the 5 halves. Alright, but before I do that, I'm going to take care of this thing. This right here, let's use our rule of calculus. When you're dividing by a fraction, you want to take the bottom, flip it, and multiply it. That's what I'm going to do in my next step. So my next step right here, I'm going to recopy everything, except I'm going to go ahead and do that flip and multiply rule. So this is going to flip. It's going to become 4 over 5. Oh, and I forgot this. It's going to become 4 over 5 x to the 5/4. And we have our plus c, which we'll take care of in the end. Plus c is just going to always be added to these indefinite integrals. So now I have this written down. All I did in this step was I flipped the bottom and multiplied, right, from calculus. Now what I'm going to do is multiply my 5 halves in, and then we'll be canceling out anything that can cancel. So then 5 times negative 4, that's going to give me negative 20. 2 times 5, that's going to give me 10. Then we have x to the 5th. Now we have minus 5 times 4, that's 20. 2 times 5, that's going to give me 10. And then I'm just going to rewrite this x 5 to the 4th. Great, and when we distribute it, let me just go ahead and put my plus c there. Awesome, now let's go ahead and reduce what we got. And it's nice because things do reduce. So negative 20 divided by 10 is going to give me negative 2, x to the 5th. Again, negative 20 divided by 10, negative 2, x to the 5/4. And then don't forget your plus c. And that is my final answer. That is my antiderivative. This is my indefinite integral. Take a look at the work there. Check that you got number 23 right. Check that Ms. Sedano did not make any errors as well. Alright, so soon I'm going to move on to number 24. By the way, you could always pause this video if you feel like you need some, pause it to understand it some more. So now I'm going to go ahead and do number 24 with you. Just got to make sure you guys are able to see this in the video. So we got the integral of negative 9x squared plus 14, the 5th root of x squared divided by 5 plus 4 cube root of x. And that's all dx. I mean, they have parentheses and dx. Okay, my first thing that I'm going to do is those square roots right there, those roots, we got to rewrite them as exponents. So remember, the root goes in the denominator, the power goes in the numerator. So that's what I'm going to do next. What I'm doing right now is just rewriting those roots. This is going to be 14 over 5, x to the 2/5. Remember, root is denominator. The power right here, it becomes a numerator. All right, and then this one right here is going to be plus 4. Because there's no power, the numerator in this case is going to be 1. The 3 is going to go in the denominator position. So all I did is I rewrote this integral. I did not take the integral yet. All I did is I rewrote it so that I can take the integral using my power rule. Good. So that's this step right here. Check to make sure that I did not make any mistakes, you know. Check to make sure you also did not make any mistakes. So math is about doing the math. If you get it wrong, then just correct it. All right, here we go. Now that I have it written in this format, I'm better able to use that power rule. So all I'm going to do is these exponents, I'm going to add 1 divided by that n plus 1. And then just keep these constants in front. So here we go. So 2 plus 1, that's 3. And then we got to divide it by 3. The 14 over 5 is just going to come in front because it's a constant. 2/5 plus 1. So 2/5 plus 1, that's the same thing as saying 2 over 5 plus 5 over 5. That's going to become x to the 7 over 5. But then don't forget, we got to divide by 7 over 5. And we'll simplify that in a second. Plus, the 4 is right here. 1/3 plus 1, that's like saying 1/3 plus 3 over 3. That's going to become x to the 4/3 divided by 4/3. And then we're going to add our plus c. Now, this answer is correct, right? But you can reduce it. And I want to push you to reduce it. It's very easy because we're using our pre-calculus rule, which is basically taking these fractions at the bottom there and flipping and multiplying. So this is our pre-calculus rule right here. That's what we're going to do next, and then we'll be done with this antiderivative. Oh, cool. Negative 9 divided by 3, that gives me negative 3, x to the 3rd, plus 14 over 5. I'm going to take this, flip it, times 5 over 7, x to the 7/5, plus, take this, flip it, so it's going to be 4 times 3 over 4, x to the 4/3, plus c. Good, so check the work there. All I did is I flipped and multiplied. Well, I'm about to multiply actually. All I did is I flipped the fractions, and I have a little multiplication somewhere right here. All right, so then this was nice to simplify to just negative 3x to the 3rd, plus, what I'm going to do, I mean, you can already start, actually, if you want to, canceling out your fractions, right? Because you can see 5 over 5 cancels, and we got 14 divided by 7. That's already going to give me 2. I could see that already. But if you want, you could put this in your calculator, just if you don't like that cross-canceling. You do 15 times 5, enter, that's 70 on top, divided by 5 times 7, that's 35, right? So 70 divided by 35 is still going to give me 2. So this right here is going to become 2, x to the 7/5. So that simplified nicely. Right here, 4 times 3 over 4. The 4s I can already cancel and see that this becomes 3. Or you can do 4 times 3, that's 12 divided by 4. Again, you get 3. So I'm just, this part right here is going to become 3. And then just rewrite that variable, and then your plus c. Alright, so as you can see, this fraction just became 2. This fraction, when I multiplied, just became 3. We are done taking the antiderivative of this problem. So this is number 24 on your homework. As you know, in class we did 20 and 21 together. And 22 was very similar to 21, so I do expect you guys to attempt that on your own. Alright, otherwise, I hope I see you after school, if you come by after school to get some help. Thank you guys.